Assalamualaikum and a very good evening to Puan Mazia. My name is Siti Nurnashika and my matrix number is 01 BMS22F3026 and this is my teammates Nurul Huda, Baid Ridwan Shah and also Muhammad Afiq Shazwan. Today we are going to present about trigonometry in architecture. So let me tell you, what is trigonometry? Trigonometry, known as the relationship between triangles and also angles and sides of the object in the mathematics branch, it is known as trigonometry. Trigonometric functions are defined based on the ratios of the lengths of the sides of the right triangle. The next slide, I'm going to talk about the definition. The first one is sine. What is sine? Sine is ratio of the length of the side opposite to the angle of the length of the hypotenuse. The second one is tangent, or also known as tan. It is ratio of the length of the side opposite to the length of the side adjacent to the angle. And the last one is cosine, which is known as cos. It is the ratio of the length of the side adjacent to the angle to the length of the hypotenuse. So for the next slide, I'm going to talk about three primary trigonometric functions. The first one are sine. How can we find sine? We can find sine by divide opposite over hypotenuse. And the second one is cosine. To find cosine, we must divide adjacent over hypotenuse. And the last one is tangent. To find tangent, we need to divide opposite to adjacent.
Hello, my name is Nurul Huda binti Muhammad Noor. My matric card 01 BMS22F3005. So today I would like to share with you guys about application trigonometry in architecture. Okay, first, measuring angles and height. Trigonometry is used to measure angles between walls, floor and other architectural elements. It helps in determining height of buildings, the slope of roof and the incline of staircases. Okay, second, roof design. Architect use trigonometric function to calculate the pitch and dimension of roofs. This ensures proper water drainage and overall structural stability. And then structural analysis. Okay, trigonometry aids in analyzing the forces and the stresses that act on architectural structures. Engineers use trigonometric calculation to design load-bearing element and support system. Alignment and symmetry. Trigonometry is used to ensure accurate alignment and symmetry of architectural features such as windows, doors, and columns. Land surveying. Trigonometric principle helps surveyor determine distance and elevation of land. This is critical for site planning and ensuring building fit within the landscape. And then calculation distance. Architects use trigonometry to calculate distance between points, aiding in creating accurate site plans and layouts. And then shadow studies. Trigonometry is used to predict the path of the sun shadow throughout the day and across different seasons. This helps in optimizing natural lighting and energy efficiency. And then window placement. Architects use trigonometric calculation to determine the best placement of windows for maximizing natural light and minimizing heat gain. Architectural drawing. Trigonometry is employed to create accurate scale drawing depicting proportions and dimension of structures. And then construction layout. Trigonometry assists in accurately laying out building foundations, walls and other structural components during construction. And then aesthetic design. trigonometry concept can be applied to create visually applying architecture element like arches, curves, and domes. And last, urban planning. Trigonometry helps in determining the layout of streets, intersections, and public space in urban planning. Overall, trigonometry is fundamental tool that architects use to translate their design ideas into functional and aesthetically pleasing structures while ensuring structural integrity and practicality.
Assalamualaikum and hello, my name is Muhammad Fijazwan bin Ibrahim. My metric number is 01 BMS22F 3003. Okay, I will explain about model explanation. Okay, the model that we choose is a building. In our case, this building use the trigonometric methods to determine the stability of the building structure in finding the right angle and size for geometric condition on the site. Okay, not only check framing or the truss, joists are also used to accommodate the load current conditions on the building structure in accordance with trigonometry function. So this is an example of our model. Is a building. So the trigonometry include when we want to make a building. So the trigonometry function to determine the stability of the building structure in finding the right angle and the right size to get a stability building.
Hello, my name is Ridwan and I will explain about the explanation. As you can see, okay, the first thing we should do is find the length of AC. As you know that E is the top of the building and the C is the bottom of the building. So what we should do is using the hypotenuse. Okay, a hypotenuse is the longest length of the building. So using the formula, square root AC equal to square root the length of AB square plus the length of BC square. Okay, so the square root 12 square plus 14 square. So the answer we get is 18.44 for AC. Okay, and the second thing is find the angle of E. E is the top of the building, so we use tangent. Okay, as you can see, tangent E equal to opposite over adjacent. So getting the formula, tangent A equal to 14 over 12. So we move the tangent to the inside, so we get inverse tangent divided by 1.16667. So the answer we get of angle of E is 49 for 40 degrees. Okay, the last one, find the angle of C. Okay, we use the sign. Okay, so if you can see, sine C equal to opposite over hypotenuse. So getting the formula, sine C equal to 12 over 18.44. So change the sign into left, so we get the sine inverse divided by 0.6508. So the answer you get is 40 for 60 degrees. Okay, that's all. Easy. Thank you.
For conclusion, Trigonometry plays a vital role in architecture, serving as a fundamental tool for architects and also designers to create structurally sound and functional buildings and structures. Structural analysis heavily relies on trigonometry, ensuring that buildings can withstand various forces, loads, and also stresses while maintaining stability and also safety. That's all from our group. Thank you.